When we start to do exercise, our body makes immediate changes in order to facilitate the change that we're making and the demand for energy that is required. We call these changes acute responses. So they're the immediate or short-term responses that the body makes, and that's in response to the demand that we're placing upon it. It is determined by a few factors. The primary factor that determines our response is the intensity. The intensity also governs the energy system which responds, and that can have a run-on effect as to the response, particularly when we consider the response by the muscular systems. Now, it occurs within the three body systems, so the cardiovascular system, the respiratory system, and the muscular system, and many of these changes aim to take in more oxygen, so to uptake, to transport, and to utilize oxygen, each of which we link to a body system. So the respiratory system is responsible for the uptake, the cardiovascular system, the transport, and the muscular system, the utilization. Let's explore these a little bit more. Our respiratory responses are those responses that are concerning our lungs, the alveoli within our lungs and the capillaries that meet up with those alveoli. So the response that we make, we increase our tidal volume. So when you hear volume, you need to think about an amount. So tidal volume is the amount of air taken in and out per breath. Makes sense, we breathe deeper when we exercise, and the reason why all these responses occur is to increase the oxygen uptake. So they're to do with air. We take in more air, therefore we take in more oxygen. Therefore, we're going to have the ability to deliver or take in and deliver more oxygen to the muscle. We also increase the respiratory rate. So when you see rate, it means number. So the number of breaths per minute, and that increases to get more air in so that we can increase the oxygen taken in. Now, when you times tidal volume, which is the volume or the amount of air taken in per breath, with the respiratory rate, the number of breaths per minute, you get ventilation, otherwise known as minute ventilation. And that is the volume or the amount of air taken in and out of the lungs per minute. That increases during exercise because tidal volume and respiratory rate both increase. So you have a run-on effect of an increase in ventilation. You also get an increase in gas exchange or diffusion. Because you've got a greater amount or volume of air coming in with each breath, that stretches the alveoli, and the alveoli are the facilitators for gas exchange. So when you get larger alveoli, you get more surface area to exchange the gas across, you get an increase in oxygen uptake, and that in turn increases the removal of carbon dioxide. Now, all of these four variables increase the ability of the muscles to produce energy aerobically. And that means if we've got a greater opportunity to produce energy aerobically, we can work aerobically at a higher intensity, decreasing the reliance on anaerobic energy, which has the associated metabolic byproduct buildup. If you can see there, this is just a picture of inhalation and exhalation. So when we inhale, you can see that our diaphragm, which is the muscle, that brown muscle there, pulls down, and we get an increase in air coming in. When we exhale, it pushes air back out. So when we take deeper breaths, you can see the lungs that we're looking at there are going to become much bigger, big deep breaths, and that increases tidal volume. If we take them more often and we increase our respiratory rate, we're going to increase our ventilation, which again is the amount, the volume of air taken in and out per minute. Interestingly, when we head towards max intensity, we get a less of an increase in tidal volume, so we don't take as deeper breaths, but we get a faster respiratory rate. So we actually start panting a little bit more, and that increases ventilation. That's right towards the maximum intensity exercise. So in a VO2 max test, you'd get a great increase in tidal volume respiratory rate to start with, and then towards the end, you just get that increase in respiratory rate. Let's take a look at some numbers. You can see here our breathing rate at rest is 12 breaths per minute. During moderate exercise, that increases to 30, and intense exercise increases to 50. Tidal volume, on the other hand, at rest, it's 0.5 of a litre per breath. Moderate exercise, there's a big increase up to 2.5, and then towards maximal or intense exercise, there's not that much more of an increase. So between rest to moderate exercise, there's an increase in breathing rate and tidal volume, and towards moderate exercise to intense exercise, There's more of an increase in breathing rate, that's respiratory rate, than tidal volume. And that equals a great increase in ventilation. You can see there the example, 6 litres per minute at rest of ventilation, all the way up to 150 litres. And the driver for that is oxygen uptake, to increase the oxygen that we're taking in, because that's what the respiratory system is responsible for. What we can see here is you can see a picture of the lungs, and if you just have a look there at the really close up, you can see that where it says written carbon dioxide out and oxygen in, that's called an alveoli, which is a tiny little sac that's present in the lung, and the capillary services that, gives it a blood supply. So we breathe out the oxygen that's being grabbed from the muscles and taken to the lungs, and we breathe in the oxygen. So out the carbon dioxide, and we breathe in the oxygen from the air. That's taken into the capillaries, then gets sent off to the heart, and then that gets sent off to the lungs. So again, the respiratory system is responsible for the intake or the uptake of oxygen. Now we're looking at the cardiovascular system. So if you imagine oxygen like a baton change, so it comes in with the respiratory system hands it over to the cardiovascular system, and the cardiovascular system carries it all the way around to the muscular system where it's used. Just as for the respiratory system, there's a rate and a volume, so too there is one for the cardiovascular system. This first one's a pretty easy one to remember, heart rate. We've known about it for a really long time. It's something that you should think all the time. As soon as you start exercise, you increase the number, rate means number, of beats per minute. Stroke volume is the amount of blood that's pumped per beat. It's pumped from the left ventricle if we're being really specific. And both of these two things increase during exercise to increase the oxygen transport and delivery to the muscle. That means that you can increase the aerobic ATP production, therefore work at a higher intensity aerobically before you rely on the anaerobic glycolysis system or the anaerobic systems to come in. When we times heart rate by stroke volume, we get cardiac output. Cardiac output is the volume or the amount of blood that's pumped out per minute, and that increases dramatically during exercise due to the demand of oxygen at the working muscle. You also get an increase in blood flow to the working muscles, and that's via a process called redistribution. Redistribution of blood flow means that we get some vessels to the muscles widening, and the word we use is vasodilation, and some constricting to non-vital organs, and that's called vasoconstriction. So that's another cardiovascular response that the body makes. It redistributes blood and therefore oxygen to the parts of the body that need it at that point in time. So really there's a pattern. For everything that's present in the cardiovascular system, it's present in the respiratory system. There's a heart rate in the cardiovascular system. There's a respiratory rate. So rate means number. There's a volume associated with both, and then there's an amount per minute that's associated with both. So make sure you learn the definitions of all of these variables and know the equation as well. Know that heart rate times stroke volume equals cardiac output. Know that respiratory rate times tidal volume equals ventilation. And all of these things increase during exercise due to the demand of oxygen at the working muscles. Just like before when we looked at respiratory rate being in charge from moderate exercise to intense exercise, so too is heart rate responsible for that change. So when you're looking at lower intensity exercises, you get an increase in stroke volume and you get an increase in heart rate. Then stroke volume plateaus off a little bit and heart rate continues to increase. So between rest to submaximal exercise, both stroke volume and heart rate increase to result in an increase in cardiac output. Then from submaximal exercise to maximal exercise, stroke volume has less of a role and it's more about heart rate that increases. So in the respiratory system, I showed you a table and now I'm showing you a graph. Represents the same thing. When we're looking at a redistribution of blood flow, if you look at the top, cardiac output during heavy exercise is 25 litres per minute. At the bottom during rest, it's 5 litres per minute. The main thing I want you to look at is over that far side when we're looking at muscles. During rest, about 15 to 20% of the blood is distributed towards the muscle, and during exercise, 80 to 85. And that redistribution of blood flow is a result of the demand for oxygen at the working muscles. Finally, we're going to look at acute muscular responses. So we look at the column on the left-hand side is the response, and then the outcome is on the right. So you'll notice with the outcome of the respiratory and the cardiovascular system, most of them are about increasing oxygen delivery, or they are about increasing oxygen uptake and delivery. At the muscular system, it's a little bit different. Some are oxygen related, but some are related more to the anaerobic systems. So let's have a look at each of them. The first one there is muscle recruitment. So muscle recruitment is the brain sending a message to the muscles to contract. When we start to exercise, either aerobically or anaerobically, you get an increase rate in the brain recruiting muscle. So brain sends a message to the muscle to contract, it contracts. When we exercise, it sends those messages faster. And during anaerobic exercise, when intensity is higher, that rate is going to be even higher. So rate increases for both, but it's going to depend on the intensity of the exercise. More intense, faster rate. Likewise, the number of muscle fibers recruited. So when we recruit a muscle fiber, if we're doing something like picking up a pen, we only recruit a couple of bits of muscle to pick that pen up. But if we were lifting a 20 kilo weight, we'd recruit a much larger number of muscle fibers. The brain's pretty clever. It looks at something that we're going to lift, it assesses how much muscle is needed, and it recruits the amount of muscle required. When we exercise, you're going to increase the number of muscle fibers recruited because you're increasing the demand for ATP and for force from rest to exercise. So the more muscle fibers you recruit, the greater the force that you're going to produce and the heavier you can lift or the harder you can work. So during more intense exercise or heavier exercise, you're going to have a greater number of muscle fibers recruited, more muscle. Bigger lift, bigger load, more muscle recruited. You also get a change in the fuel that's used. And you can see there that it's written increase in fuel metabolism. So that means breaking down fuel, and therefore you get a decrease in fuel stores. Now, when you break down fuel, you increase ATP production. So the outcome of fuel breakdown is you get more ATP resynthesized or ATP produced. Now, the fuel that's going to change in the muscle depends on the intensity of the task. If you're doing a maximal intensity exercise, you're going to deplete which fuel? CP is going to deplete fast. So therefore, you're going to have decrease in CP stores. If you're doing a lower intensity exercise, you might be using more fats and carbohydrates. Therefore, you'll get a decrease in fats and carbohydrates within the muscle. So that third one, the change in fuel stores, is largely dependent on the energy system that's recruited. It's also dependent on how long you work for. If you only work for 5 minutes versus working for 2 hours, you're going to have a greater decrease in fuel stores at the end of 2 hours as opposed to the 5 minutes. So it definitely depends on intensity, and it definitely depends on the duration of the task as well. You get an increase in muscle temperature regardless as to the type of contraction that's occurring. Of course, we know that heat is produced as a result of aerobic breakdown, and it's an aerobic byproduct. So you definitely get a larger change in temperature for a longer aerobic type event, but you also get an increase in muscle temperature for any type of exercise. It's just that the longer you work, the more fuel you've broken down, therefore the greater the byproducts, therefore the greater the temperature change. Increase in AVO2 difference. So AVO2 difference is the difference in oxygen concentration from the blood coming in to the blood going out. So what that means is that you've got the opportunity to take out more oxygen when you exercise. So the blood coming in versus the blood coming out, you get greater oxygen extraction during exercise. Therefore, you get a greater AVO2 difference. We'll cover that one more in class.